Okay, because it was when I wasn't here. All right. So, first thing we need to do is simplifying radical expressions. Remember, when you simplify radical expressions, you use a factor tree. We've done this stuff this year. And then you look for your groups of 2. So you do a factor tree and you look for groups of 2. Do you guys know what I mean by a factor tree? I hope. So once you find your groups of 2, you take anything that's circled, you take 1 and it goes to the outside, and if it doesn't have a partner, it stays underneath. So this is really annoying. Just keep squeaking. Okay, so that's what we need to remember.
Should you do this? And I'm like, yeah.
If there is a partner,
One goes.
Oh, goes. That makes more sense.
Just a little bit, right? But I mean, also I don't write the cleanest, so you can always ask. Stay under. Yeah, that's the word under. Okay, so now the square root of 1, these are all perfect squares, but the square root of 1 is 1. Now, we often, you guys might already know this, but the square root of 4 is what? 2. Well, if you do a factor tree, 2 times 2 is 4. That means you have a group of 2's. You take 1 out. Is there anything left on the left by itself? So that's why there's no more radical. Does that make sense, kind of what I was saying in those step-by-step instructions? We've done this before. Remember when we did distance formula, we did the factor trees to simplify and stuff like that. So this is not new to this year even, and you guys did it last year a little bit too. So what's the square root of 9? Square root of 16 is? And so this is a little bit different here, because 16 is 4 times 4, which is 2 times 2 and 2 times 2. Just want to show you guys this one too. So we have 2 groups of 2, but we have nothing left without a partner. Do you guys see how we have nothing left without a partner? So that's why the radical has disappeared. So you have 2 times 2, which is 4. So that's where the 4 comes from. What is the square root of 25? How about the square root of 36? What's the square root of 49? 64. Square root of 81 is? Square root of 100 is? Thank you. All right, so those are all perfect squares. Perfect squares mean that there is no more radical. It means that the same number times the same number, so the same number times the same number can multiply to get that number, which means it actually has a square root. All right, so go ahead and flip to the next page. I hope so. I know you can do it. It's more of like, I hope you will give the effort.
I'm like actually like
Okay.
my brain's like saying,
Rob, like, just do it. And then it's like, or you just sleep in that chair. And then I'm like,
no, stop.
I do love that hoodie though.
thank you.
It's fantastic.
Appreciate it.
It's like a classy hoodie. Not right now. We will be doing proofs though this semester.
All right, that's where I'm scared. Now
You always do
Miss
it.
Brady, I'm gonna have to like see you.
I understand that. Okay, a radical expression is any expression containing a radical symbol. This is a radical symbol. Do you know what the inverse of a square root symbol is? What's the inverse of square rooting something?
2.
It does have to do with the 2, actually. I know it's not actually just 2.
Isn't
What?
Squaring.
Squaring, yeah. So good job, girls. So Casey was right. The number 2 does appear in squaring. So those two are inverses of each other. So if you have a cube root, the inverse of a cube root is, cube means 3, so to the 3rd power. So it just goes on with that. But anyways, so for the square root of x is called the radicand. So the number underneath is the radicand. And the radical or the square root symbol is what is on the outside. Okay, so let's simplify some of these. Rob, what goes into 50? What are numbers that multiply into 50?
25.
And 25 times what? 2. So 2 is a prime number, so I'm going to circle it. Prime means it can only multiply by 1 in itself. Composite means that it can multiply by more than 1 in itself. What goes into 25, Rob?
5.
Okay, so we have all prime numbers there. So we have 2 times 5 times 5. So we look for our partnerships. Do we, Carmichael, have any partners? What is it?
5.
Okay, so Lindsay, how does that write up when you simplify it then? Perfect. So you take 1 from the circle, and it goes to the outside, and the one that does not have a partner has to stay on the inside. Okay, this has a 4 on the outside. What does that mean we're going to do with the 4 at the end there, Morgan? What does that 4 mean we'll do? Oh, I don't know. I think you just left this in my room.
I didn't really want it.
I figured. Do you figure out what to do with the 4 at the end? Desiree, I think I forgot to give this to you last semester. So, does anybody know what the 4 does there?
Whenever you have all of it done,
Mhm.
then you multiply whatever you have left. That's going on the outside.
Yeah. So if this had a 4 out front, we would have done 4 times 5 at the end. So you just multiply that outside number. So first we have to do our factor tree. Greg, what goes into 27?
93. No,
Okay, guys, be careful. A lot of kids think 9 is a prime number. It is not a prime number. Gabe, what goes into 9? 3 times 3. So, Iku, do we have any partners?
3.
Okay, so what does that part specifically, before we deal with the 4, simplify to?
3.
Square root of 3. So then we take down the 4, and we do 4 times 3, which is 12, square root of 3. Magical. No? Okay.
I'm just not happy.
I'm sorry.
I'm actually like sitting here.
You're taking notes. I'm
My
proud
brain-
of you.
My brain is like.
Daniel, what goes in 132? Times what?
11.
So 11 is prime. Harmony, what goes into 12? 2 is prime. 7, what goes into 6?
3 and 2.
Cameron, where are my partners in this one? 2 times 2 times 3 times 11. Okay, so that becomes what, Cameron, then?
12
So it will eventually become 12. So that's 2 square root of 33, because you do 3 times 11, which is 33. And as Cameron said, you multiply the 6 times the 2, which is 12 square root of 33. Very good. I am getting very frustrated by the squeakiness of this. Okay, last one on there. Desiree, what goes into 72?
9 and 8.
Perfect. Again, 9 is not prime. Do not circle that. Logan, what goes into 9? And 8, Logan? So we have to keep going. 4 is 2 times 2. Wow, what's up?
So, today, on Thursdays, is a buy one get one free
Where?
at Buffalo Wild Wings.
Okay.
No,
Pretty sure if I were to buy 22 wings, I get another 22 wings.
I just don't really care for Buffalo Wild Wings. They don't have that great of wings.
Are you more of a Wingstop kind of person?
Yeah.
I get it.
Okay. Do you guys have any questions on just simplifying? Do you guys have any questions on simplifying? You forgot to multiply it by. How did you get negative 10? I don't even know. So you see how it's 3 and 2? So that pulls a 6 out. Do you see that now?
Yeah.
I think you did it the opposite. You did. You pulled. Do you see what I'm saying? You took the non-partnerships and pulled it out instead of doing. Does that make sense? Okay. Anybody have questions on anything on this page before we keep going? I feel as if this is getting redundant. Do you guys feel like we need to do these? I don't even need you to try them. I would like you guys to be able to try to get to your homework today. Okay. So we're going to skip those examples so we can try to get to your homework instead. I feel like that is a little bit redundant there. All right. If you want to try them, you can, but I am going to move on to the requirements to add or subtract radicals. You must have like radicals to add or subtract radical expressions. So think about this. If you have, so this is just a side example. If you have 2x plus 4x, you can add those, right? Because they both have x. And that becomes 6x. Do you guys agree? But if you have 2x plus 2x squared, can you add those? Can you add 2x plus 2x squared? No, that is just simplified by itself. So this is just a side example to get us understanding what I'm doing here. So your like radicals are like your x's. So like radicals are like your x's. Do you guys see how these all have a root 2 here? This is like having 3x, 4x, and 25x. So if you were to add these, if you were to have to add these, you would just add the front numbers. 3 plus 4 is 3 plus 4. 7 plus 25 is
32.
32. Okay, what do you think is under the radical then? Just 2. Do we change the x when we do 2x plus 4x? No, the x doesn't change, so why should the radicals change? What this is saying is we have 32 radical 2's, essentially is what that's saying. So for it to be a like radical, it has to have the same number underneath the radical. What is in front of this radical here? 1. It's just like when we write x without that. Yeah. It's just like when we write x without like the 1 in front, that also has a 1. So you might want to put that in whenever you see that so you don't forget that. Yeah.
How do you know if you're going to add or subtract?
That I'm just showing you a random example. It will actually have the symbols in there. Yeah. Unlike radicals, do you see how this one has a radical 2, this one doesn't have a radical at all, and this one has a radical 5? That will be like trying to add x and x squared with a constant. You can't do that. So you have to have the same number in the radical. Does everybody understand what I'm saying by like radicals? Okay, go ahead and flip to the next page when you're ready. Only this. Nothing new.
like algebra.
Wait.
So, the first thing you always have to do is look to simplify your radicals if possible. So the first thing you need to do is look to simplify the radicals if possible. So we have radical 3. Can radical 3 be simplified? You can do a factor tree for radical 3?
No, you can't.
No. So none of these can be simplified. So from there, you just add.
I think you meant something.
I knew what you meant. Yeah, I figured that out because you had the answer already down. So you add, subtract, like radicals from there. So we don't have to simplify these radicals. They're already simplified. Are these like radicals? Yeah. So we just add the front numbers. 4 plus 6 is? 10 minus 5 is? 5. Do we change the radicals at all? No. So it's just 5 radical 3. Yeah. Do you have a question or you just? No. Okay, can you simplify radical 2? Can you simplify radical 16? Yeah, 16 is 4 times 4. This is so annoying. Yes, it's terrible. 2 times 2 is? What's 2 times 2? So 16 radical 2 plus 4 is really what that is. Are those like terms? No, be very careful because I see a lot of you guys when you see something like this doing 16 plus 4. Can you add the 16 and 4? No, this would be like 16x plus 4. Can you add 16x plus 4? No, it just stays the same. So that is your answer. Okay, example 3, we have to simplify each of the radicals first. So Carmichael, what goes into 20? What goes into 4, Carmichael? Okay, so what does that simplify to? And don't forget this 2 here, Carmichael. So what does that simplify to?
5.
Perfect. So 2 comes out. 2 times 2 is 4. 5 doesn't have a partner, so it stays underneath the radical. So that's where it's coming from there. Emma, what goes into 45? 5 and what? Yeah. And what goes into 9? I can't. I don't have one. I need to buy a new one. Yeah, but that one's like falling apart.
Okay, well that one's
Well, that one is obviously not as annoying, though.
I will look for it in a second here. Emma, what does that simplify to? What'd you say? So the one that has the 2, like if it's a partnership, you take 1 to move to the outside. So you'll move what number out to the outside? 3 will go to the outside and you multiply that by, which is? And what happens with the 5? Yes. I was talking to Emma this whole time, but thank you, Greg, for the echo.
Gosh, Greg.
to help me.
What?
There's one at Walmart for $2 and then 7 and some.
I know, I buy them from Walmart.
Don't get the one that's $2. 'Cause
They're in
then
aisle
that mistake will
17.
happen again.
Okay, Jill, 18.
I'm just kidding.
I don't have that much money.
It's not even like a beaded salt. I get it.
What goes into 9, Jill?
3 and 3.
So, what does that simplify to?
3.
You just look like.
It's a rough time right now, guys.
Oh no, I already have this
Look at you.
Laughing because you like the face you made. You were just like, I'm done with this.
because I know that tomorrow we're gonna learn something.
You did learn this lesson.
completely different.
This is how math is.
Yes.
No, this is
All over it.
It's because this was like the first stuff you learned when I left.
I think that's what I actually.
Yeah, like this is like the first 2 weeks when I left. You guys were learning this. All right. So these, you guys noticed that before these weren't like radicals? Do you guys see how you noticed before that they weren't like radicals? Are they like radicals actually after we simplify them?
No.
2 of them are. So can we at least add 4 and 9 together?
Yeah.
What's 4 and 9? So that's 13 radical 5 minus 3 radical 2. Okay, I'm not going to do the next page with you guys. I'm going to let you guys